Greetings everyone. Today we are going to review all of our basic exponent rules. So we are going back to the Algebra 1 level rules, but we're going to combine them more to make it Algebra 2 level. So make sure you have the foldable for this. There's sort of a lot to jot down. And as always, at any time, make sure to pause if needed. Let's start off with all the rules review. So just reviewing the basics. When we talk about what an exponent is, an exponent means you take the base times itself as many times as it says. So for example, this means I have a negative hanging out front, which is technically a -1, and then I have a 2 5 times. All right, and then if I look at the x, right, that means I have times x 4 times. And so I bring this up because if you ever struggle with remembering a rule, by quickly doing an expansion like this, it can help you remember what to do. So you have a backup plan if you don't have a good memory. Of course, with numbers such as this, you can use your exponent key, your caret top key, and you would arrive at a -35, and then the x to the 4th would stay. All right, let's review and refresh our memories on negative exponents. Negative exponents are not allowed to remain negative. And so to make them positive, we move them to the other side of a fraction bar. So one of the first things I encourage you to acknowledge is how many bases you have. We have a 3, we have an x, we have a y, we have a z. Treat them as separate pieces. So the 3 has technically a +1 exponent, it stays. The x has a negative, so it gets kicked to the denominator and becomes positive. The y is positive, so it stays. And the z is negative, so it gets kicked to the other side and becomes positive. The product rule. Now, the product rule is one of the easiest, but it's also one of the most challenging to remember. And so the rule says when multiplying things with the same base, acknowledge this, same base, all you have to do is add the exponents. And so I'm going to rewrite this problem first of all. These parentheses are unnecessary, right? Those parentheses are just showing me that in the end, we are just multiplying. All right, and then I can take a look. I have x squared times x to the 4th. Now, it says to add the exponents, which would be x to the 6th. Add the exponents, which would mean it's y to the 9th. Now, easy to forget. Let's say you do forget on a learning check or something silly. Do a quick expansion, right? 2x's, 4x's. Oh, that's 6x's. So see how you can quickly remember by just counting. The quotient rule is the opposite of the product rule. So when you're dividing things with the same base, make sure to underline that, you subtract the exponents, right? So when multiplying, you add the exponents. And when you're dividing, that becomes subtract the exponents. So they're opposite rules. Again, acknowledge the pieces. We have technically 3 bases in the numerator and 3 bases in the denominator. I'm going to talk piece by piece. Let's talk about 2/6. That's a regular old fraction. That's just a 1/3. That's not even anything special. So 1/3, deal with fractions as you normally would. Now I'm going to show you my shortcut. Okay, this is a Mortvet shortcut. I do want to subtract these, but to make the process quicker, subtract from the larger one. That would be the denominator. And then it remains positive. So 3 minus 2 is 1. Okay. Now, why is that the Mortvet sort of cheat way? Because technically, don't write this down, but technically this would be p to the negative first, and then the negative would kick it to the bottom. Do you see how I just skipped that middle step? And so if you subtract from the larger, it just makes it a little faster. All right, and then let's talk about the q's. So q squared over q to the first. That means q is larger in the numerator, and 2 minus 1 is 1. Power to a power and power to a quotient go together. So when you have power to a power, you distribute the exponent and you multiply the exponents. So again, acknowledge how many bases. There's 3 to the first, a to the second, b to the first. We're going to distribute the 2 to every exponent. Now do not jump ahead of yourself. I encourage you to write the bases. Then distribute. 1 times 2, 2 times 2, 1 times 2. Then I'm going to take a look at the second piece. There are 2 bases, so 2 distributions. I'm going to write the bases first. 2 times 1, 4 times 2. Now that I've removed parentheses, I have 5 bases. Let's simplify what we can. I know that 3 squared is 9. I know that 2 squared is 4. These are all being multiplied. A to the 4th times a to the 8th. When we multiply like bases, we add the exponents. And then there's only a single b base, so it's going to hang out. And so one of the most common errors I see here is the 9 and the 4. And all of a sudden people are adding numbers? No. This just says 9 times 4. Don't make it more challenging. And if you need to, draw those dots so you don't make silly mistakes. All right, power to a quotient. Similarly, when you have a power to a fraction, every base has an exponent that gets multiplied. And so again, I encourage you to rewrite every base. There's an x, there's a 3, there's a y. I'm going to distribute that 3 to all 3 pieces. 7 times 3, 1 times 3, 2 times 3. If there's nothing to combine them with, they stay, and if you can simplify, you need to do so. Zero, my favorite rule. Anything to the 0 power is 1. This is all to the 0 power, and what some of you are going to do, some of you might write it like this. You might actually distribute. But wait, that'd be a 1, that'd be a 1, that'd be a 1. Everything becomes 1. You could do the entire alphabet. You could say math. As long as it's all to the 0 power, it's 1. Doesn't matter. The last rule that I'm going to refresh your memory on is going way back to adding and subtracting like terms. Remember, in order to add or subtract, they need to be like terms, meaning, let's go back in the day, a 2x plus a 3x is a 5x, right? Or 2x squareds plus 3x squareds are 5x squareds, okay? They have to be like variables with like exponents in order to be like terms, okay? So let's take a look at the parentheses first here. I have 3 bases, and I'm going to distribute that 4 to all of them. There's my first rule. Then I'm going to simplify 2 to the 4th because that's the only thing I can see that I can do right now. So that'd be 4, 8, 16. Now take a look. This is going to be very important in your homework and on learning checks. So if anything, this is very much a review, but also very often forgotten. See how I have the same bases and the same exponents? That means I can subtract them. If I have 3 of those, and I am subtracting 16 of those, I'm going to rewrite those. I'm being very generic. 3 of those subtract 16 of those is negative 13 of those. negative 13 of those. Do you see how that happened? When adding and subtracting, you keep those like terms. No matter how high the exponent is, it has to be the same in order to add or subtract. So if you would, maybe put a star by that, because I want your attention being drawn to that during homework and practice. Alrighty, the next thing we're going to do is work through some pretty heavy examples. I'm going to go pretty quickly through these because it is review. And we are going to use a combination of all the rules. So as in any math problem, if you will, I'm going to deal with parentheses first. And so my brain says rewrite all the bases. 3 gets a negative 2, 2 times negative 2, 2 times negative 2, 1 times 2, and 5 times 2. See how I only did one rule? I do not suggest trying to do more than one rule at a time, because believe it or not, the 3 is where students start messing up. So next, I'm going to move my negative exponents. The 3 gets kicked to the bottom. The w gets kicked to the bottom. The x gets kicked to the bottom. The 2 squared stays in the bottom, and the x to the 10th stays in the bottom. That means I just have a 1 left over. Now I'm going to take care of this 3 squared and this 2 squared now. Now they're next to each other. Technically, there is dots between all of this. And so my final answer, 9 times 4 is 36. I have 4 x's and 10 x's. When I multiply like bases, I add the exponents. And then I have w to the 4th. Now, if you had the x and w flip-flopped, that'd be fine. A lot of times we try to write alphabetical, but it's not incorrect to not have it alphabetical. All right, this next one does not have any parentheses. So my first thought is I'm going to cross off that y to the 0 because that's 1. And so I don't need to work with it any further. I'm going to keep everything if it can stay. Negative 6 is a regular old number. X to the first goes to the bottom. Z squared stays. All right, let's look at the denominator. Negative 42 is a regular old number. X squared gets kicked to the top. Y to the negative 5th gets kicked to the top. And Z squared gets kicked to the top. Do you see how I did one piece at a time? All right, let's simplify things. I see a negative over a negative. Well, that's positive. I see 6 over 42. That reduces down. 6 over 42 is the same as saying 1/7. All right. The next thing, I have 2 z's and 2 z's, so I have 4 z's. I have x squared over x to the first. When dividing like bases, you subtract the exponents. So you can put a 1 or just leave it off. That's up to you. And then y to the 5th is just hanging out. Now this one I did try to put in alphabetical order. Okay. Alrighty, now that's one approach, you guys. I just want to show you something really quick here. You could do the subtraction rule right away. You don't have to write this down. Let's just talk about this for a moment. Let me address right here. Negative 1 is larger, right? And so if I think of those rules for a second, negative 1 subtract negative 2 is 1. That's how I got x to the first. All right? And then if I take a look at z's, right? Let me just color code it here. Let's say you were looking here. You don't have to move the negative, right? You can use the subtraction rule and you could say 2 subtract negative 2 is 4. That's how I got z to the 4th. All right? So keep that in mind. Your work could look different. The order in which you take care of the rules doesn't matter. Okay? But I am confident that this would be my final answer. All right, let's take a look at this next one. I have a plus sign and a times sign. Oh boy. let's go back to PEMDAS. PEMDAS says we multiply first. So I'm going to ignore the first part. This is a regular old multiplication, meaning there are dots between all of these. Okay? So I have a 2 times a 3. That's a regular old 6. X to the 4th times x to the 1st. That's x to the 5th. Y to the 5th times y to the 3rd is y to the 8th. Okay? Next, I see that I can distribute. I have parentheses here. And so I'm going to rewrite each base. 3 times 1 is 3. 3 times 3 is 9. 3 times 2 is 6. Okay? Let's take care, and there's a big old plus sign in the middle here. Let's take care of 5 cubed. I think that's the only thing I can do so far. So that would be 125. Now let's take a moment to address these terms. I kind of want to add these, right? But take a moment. Are these like terms? Are these the same? No, they're not the same. If they're not the same, I can't add them, which means this messy thing is my answer. They need to be like terms to add or subtract, okay? And then don't forget those PEMDAS rules. Multiply first. Oh, look at this fun one. All right, let's see what we can do first. I want to take care of this messy denominator, so I'm actually going to write right below the denominator. I'm going to ignore the numerator for a moment, okay? So the first thing I acknowledge is that there are 3 bases, and I'm going to distribute a 4 to the 4th. 4 times 4, negative 2 times 4, right? And then I see this minus 37. That's just going to chill there. And then I see that I have a base of x and y, and I'm going to distribute. 8 times 2, negative 4 times 2. I'm going to keep going with this denominator for a moment, okay? Let's see. I have 3 to the 4th. 3 to the 4th, I'm getting 81. That's the only thing I can do. Look at these other weird pieces. Now, before you move that negative 8, take a look. We have the same piece. These are like terms. Like terms. That means I can actually subtract. So I'm going to subtract this. 81 subtract 37 is 44. And I keep my like terms. Wow, all of that was just the denominator. I'm going to take a moment to rewrite my problem here at the bottom. All right, so my numerator says this. Oops, sorry, that's a y. And my fancy new denominator says this. One more step, okay? First, I am going to take care of negative 4 44ths. Negative 4 over 44 simplifies down to negative 1 over 11. See what I did there? Next, let's talk about the x's. X is larger in the denominator, so it's going to stay. 16 minus 14 is 2. Next, let's take a look at the y's. The y's are larger in the numerator. And 11 subtract negative 8 is 19. Or maybe you kick this up and then you get the 19, right? Which way you choose to do that is up to you. This is my final answer, okay? So working horizontally on these problems kind of works better. So it might have gotten a little confusing just because we were going vertically. So consider you're welcome to use your own paper, lined paper, if that helps. Alrighty, I have power of a quotient, power of power. I have a lot of distributing going on here. So one of the first things I'm going to do is say, hey, I don't want to deal with that 0, so I'm just going to cross it off. My personal suggestion is to write every base as is. I promise that over my years of teaching, I've realized that this allows for less errors, less silly errors, okay? So I'm going to multiply every exponent by 2. So negative 2 times 2, negative 8 times 2, negative 2 times 2, 7 times 2, 3 times 2, 1 times 2. See how you can do that quickly if you already have the bases written? All right. Next, I'm personally going to move the negatives next. X to the 4th goes to the bottom. Z to the 16th goes to the bottom. 3 to the 4th gets moved to the top. X to the 14th stays. Y to the 6th stays. And Z squared stays. See how that organized it pretty quickly? Lastly, 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is 81. I have a common base. I'm multiplying bases. Therefore, I add exponents. So I have x to the 18th. I've got a single y. And I'm multiplying like bases of z's. So I add the exponents. That is my final answer. All right, let's take a look at our last example. All right, now you'll notice there's parentheses with a dot in between. Really, that's unnecessary, right? Because in the end, it's one just big multiplication problem. The fact that there's parentheses is irrelevant. And so I'm multiplying things that I can multiply. So 2/5 times 10/7, we multiply fractions straight across, right? So we would have 20/35. When I multiply like bases, I'm going to try to color code here actually. When I multiply like bases, such as my x's, I add the exponents. So 17 plus -6 is 11. Let's take care of the y's. When I multiply like bases, I add the exponents. -14 and -5 is -19. So for my final answer, I'm just going to set up one big fraction bar here, all right? So 20/35 reduces down to 4/7. The x is positive, so it remains on top. The y is negative, so to become positive, we kick it to the bottom. That would be my final answer. All right, so I know that was a lot, partially because this is actually more of an Algebra 1 lesson. The length of the problem sort of made it Algebra 2, but all of these properties we learned in Algebra 1. Also, we gave you these long examples to help you with the homework. And so just make sure, if you get stuck on a homework problem, please come back to this video and find an example that looks like it, because we purposefully wrote these for that reason. As always, make sure to check out Google Classroom, see what your task is. If you need to re-listen to some of this without writing, I always encourage you to do that if this is a topic you struggle with. And until next time, I hope you have a good one.